Hey guys, so in this video what we'll be going through is the chess configuration challenge from AI Blitz 6. What are we doing in here? Let's scroll down. Chess veterans can take one quick look at the board and plan their next moves. This puzzle is all about teaching your AI to identify the chess configuration given an image. See, you're given an image. Now you have to understand what is the configuration of this chessboard. So that's exactly what we'll be looking at in here. Given an image, or given the data set, contains images of chessboards with pieces of both black and white. Each image of size 254 by 254 pixels, fine. A CSV provided contains the image ID and the configuration of pieces. Cool. The dataset is divided into true and valid, fine. So when you look at the CSV basically like this. You have under the image ID, you have the image ID, and then you have the whole configuration of the chessboard as a label. Let's see what we can do in here. Fine. So again, this is our classic pattern that we see in here. We have the train and the val CSV. Val CSV contains 4,000 samples, while the train CSV contains 40,000 samples, sorry. And while all these samples are basically the rows in there, you have one column as the image ID, you have the other column as the labels. And the labels are again, well, configurations of the chessboard that is given in here. So the configuration of the chessboard is calculated using the Forsyth-Edwards notation. Let's see what this is. What's FEN? Yeah. FEN is the abbreviation of, standard notation to describe positions of a chess game. Fine. Why is Yeah. Lowercase letters describe the black pieces. Mind it, the lowercase ones describe the black pieces. P stands for pawn, R stands for rook, N stands for knight, and B stands for bishop, Q stands for queen, and K stands for king. Cool. The same letters are used for the white pieces, but they appear in uppercase. Okay, controversial. Empty squares are denoted by numbers from 1 to 8 depending on how many empty squares are between two pieces. So this is something really insightful that the team has noted in this hyperlink. Go check it out when you check out the dataset. And so we see in here, what else do we have? We have the train zip, we have the val zip, we have the test zip. The test zip has 10,000 samples or images of these chessboards. Val zip has again 4,000, while train zip has 40,000 images, as we discussed before. Let's talk about the submission separately. Apart from that, evaluation criteria would be the word error rate. Let's see, what's word error rate? Is a common metric of the performance of a speech recognition or machine translation. This is the formula for word error rate. Super cool. So you can also check it out more about it from this hyperlink. And forth we go. You know what? Let's take a look at the baseline now. So as you can see in here, just like any of the baselines, it starts off with us downloading the necessary packages. And okay, we're going to download the data because without the data, what can you do? So we put in our API key. So again, if you don't know how to put what's your API key, go to this link by using Control+Click, which I do this side, and it will take you to your personal profile on AIcrowd. And there under API key, you can find your API key and you can use your key to put it in here. Since I've already done it and it's a little bit private, I haven't put it out. And also I've run this cell, so I don't have to run it again. So put your API key in there, run the cell, and it will help you download the data. Run this cell and it will download you all the zip files and the CSVs. Now let's go down in here. mkdir dir data. So what this does is make directory. It makes a separate directory for data. It unzips all our files into this data directory, and it moves, MV means moves, all our CSV files to the data directory. Cute. So then we go down. Let's talk about these packages that we're using in here. So firstly, we're using pandas as PD. Okay, so when it says pandas as PD, it really means that we are just importing pandas. We're going to be referring pandas as PD. Fine. Pandas would be used specifically dealing with the CSV files, as you said, a powerful data analysis and a manipulation library for Python. Yeah, it is. And mostly the use of pandas would be related to dealing with the CSV files. What's fastai.vision.all? Well, fastai is another library that we just installed up here. As you can see, pip install upgrade fastai from this git link. Cool. Then we go down. Yeah, where were we? So fastai is a very accessible deep learning library that is used for all sorts of deep learning tasks, including machine learning, tabular data, and images for like CV, and then we have NLP too. So you get the idea. OS for dealing with the files. TQDM.notebook. Okay, so we use TQDM to note down the time that it's taking. TQDM is also very useful in understanding how long will it take to do something. Then we see pd.read CSV. We are going to grab the sample CSV to take a look at it. Fine. The main mode of this video is not to help you or teach you how to train a model or like what exactly happening there, but rather help you understand the process of how exactly would you submit a file. So there's the sample CSV. Fine. So as you can see, we have the image IDs in here. We have the labels in here. As you can see, we have R7. Then in the next line we have P1, K4, Q. So you get the idea of what is exactly happening in here. Let's go down. And in the sample submission, we have 10,000 rows, which represents the 10,000 files in the test zip that we just unzipped into our directory, which you can look up in here. As you can see, just go to data, go to test, and you'll have all these files coming up in here. Fine. Let's scroll down. Creating a random submission. So we'll be creating a random submission for which we'll be using the Rosetta code, which basically generates these random labels. I mean, these labels are random. You can check the Rosetta code out here. Come on, open up. In the meanwhile, let's look at this. So what exactly is happening in here is that we'll be creating fake labels. And yeah, so we'll be using fake labels. We're going to be predicting, going to grab some predictions in here. Let's do this. Cool. So what does predictions actually looks like? I'm actually curious. Yeah, so we have our fake labels that we generated from this whole piece of code that was again grabbed from Rosetta code, which is basically a way to create these labels. Fine. You can read about more in here. Cool. I mean, this looks pretty dope though. These configurations. I mean, predicting on them with a real model, that would be really fun. And now, since we already understand that we have a sample submission, as I told you before, these image IDs are specifically for the images that exist in the test zip that we unzipped into our test folder. Right. So what's this? Well, this is the sample submission. We'll be using, what we did was we interchanged the label column from sample submission to predictions, which was a list of all these random predictions that we just made. Let's take a look at that. And as you can see, we have our random predictions in here. Super cool. Now, since we have our predictions done, what we can do is we can export this CSV out as we try to submit it. Fine. Now, submission create. So, folks at AIcrowd made sure that it gets even easier for you to submit your stuff. So, as you can see in here, through this piece of code, we can submit our stuff. So, submission.csv, this is the path of where exactly is the CSV file stored. And we run this. See, it's finally running. Okay. Our submission's done. Yeah, download the file. And our file has been downloaded. This was super easy. This was awfully easy. Damn, not awfully, it's astonishingly easy, right? I mean, yeah, so this is the video. I think we're done here. Apart from that, if you want to separately submit your stuff to AIcrowd, what you could do is go to the, just go and create a submission in the challenge that you want to do. Since you have the submission file downloaded, we're going to go here and we'll be like, since I want to create my submission, I clicked on this one and I got in here, and I'm going to drag my submission and drop it here. It's going to upload the whole thing. File uploaded. We're going to submit. Submission accepted. We're done. Easy peasy. That was fun. Thanks for watching.